Hello students, and welcome to our lesson, chemistry lesson. So today we're going to look at electrochemistry. So this is the fourth topic in the Form 4 syllabus. So electrochemistry deals with the study of production of electrical energy from chemical reactions and the chemical changes produced by the electric currents. So the topic deals with three main parts. The first part is the oxidation and the reduction, which we are aware of. We have some information about. Then we are also going to look at the electrochemical cell, also known as the voltaic cell. Then we'll look at the electrolysis. So under this, we're going to look at both the binary electrolytes and the non-binary electrolytes. So for today, we're going to start with the first part, which is oxidation and reduction. So our first part, we are going to look at oxidation and reduction, and we'll look at that in three ways. We're going to define these two terms in terms of oxygen, also in terms of hydrogen, and also in terms of electron transfer. So our first part, in terms of oxygen, that part you looked at it maybe in your Form 1 work, whereby you said when you add oxygen to a compound, you say you've oxidized it. So based on oxygen, then oxidation is addition of oxygen, and the opposite is true. Reduction, therefore, is removal of oxygen from a substance. A good example is when we react copper oxide plus hydrogen gas. So once you react these two, hydrogen takes the oxygen from copper, so we normally end up forming copper solid plus some water. So we say hydrogen has been oxidized. It has we've added the oxygen to the hydrogen, so hydrogen has been oxidized and copper has been reduced. We've removed the oxygen from the copper. So if you are keen, you should have noted that both two processes occurred at the same time. Copper was being reduced, hydrogen was being oxidized. So such a reaction in which both oxidation and reduction are taking place simultaneously is known as a redox reaction. Redox from reduction and ox from the oxidation. So both processes are taking place together. Then in terms of hydrogen, you say that oxidation is removal of hydrogen from a substance. So if you remove hydrogen from a substance, then you say you've oxidized that substance. And the opposite is gain of hydrogen, which is reduction. So reduction is gain of a hydrogen atom. A good example is when we react chlorine gas with hydrogen sulfide gas. So once you bubble or you place a bubble hydrogen sulfide into a jar containing chlorine gas, sulfur is oxidized. In short, the hydrogen in the hydrogen sulfide is removed and we end up forming sulfur. So we say sulfur has been oxidized. And chlorine, on the other hand, we've added hydrogen to it. That's why we formed hydrogen chloride. So we say chlorine also now has been reduced because it has gained the hydrogen atom. So it is important because not all reactions will involve either the oxygen and the hydrogen. So it is important for us to get another definition now based on electron transfer. So and the best example which we're going to look now is the best example is the displacement reaction. So using displacement reaction, so we are now going to see to define oxidation and reduction based on the electron transfer. So again, in terms of electron transfer, oxidation is defined as the loss of electrons, and on the other hand, reduction is the gain of electrons. So we're going to use one example here of a displacement reaction. So we're going to react we're going to react copper sulfate with zinc. Of course, we know from the reactivity series, zinc is more reactive. Otherwise, if you interchange, if you react zinc sulfate with copper, copper cannot be able to displace zinc, because zinc is more reactive. So whenever we have such a reaction, then of course, so the copper sulfate, which is in solution, is displaced, and we end up forming the brown copper solid. So remember, this one is always blue in color. Then on the other hand, zinc goes into solution. It forms the zinc sulfate solution. So I want us to, from this equation, we can derive the ionic equation. We can exclude the spectator ions. And once we derive the ionic equation, then we should have something like this. Copper, here it is in solution. It is in solution. That's why it is an ion. So copper ion plus zinc solid should give us copper solid. It has been displaced. Then zinc has gone into solution. Zinc has gone into solution. So this is our ionic equation. So from this, we can see there are two major changes that have occurred. The first one, we can have a look at copper. So we can derive two half equations from this. So what is happening to copper? At the beginning, copper is in solution form. So copper is in aqueous state, it is in solution form, and as it reacts, what is happening? Copper is gaining 2 electrons. You ask yourself, how did this copper get here? So this is an ion, and because this is a metal, it means it had lost electrons. That's why it is in aqueous state. It is an ion. So in order for it to get here, then we must return the electrons that it had lost or it had used in sharing to form the copper sulfate. So we add 2 electrons, and once we do that, we're going to form copper solid. So that's the first one. We can also have for zinc. So initially at the start, zinc is a solid, it's an atom, and once it reacts, what is happening? Zinc is losing 2 electrons. So we are forming zinc aqueous, then plus 2 electrons. So these are the 2 half equations for the 2 processes. So first one, copper is gaining electrons. So we've said in terms of electron transfer, when we gain electrons, then that's reduction. So we can say copper is being reduced. Copper is being reduced because it is gaining electrons. On the other hand, zinc is losing electrons. So zinc is being oxidized. So this is another example of a redox reaction where both oxidation and reduction are taking place. So something else that you should note is that, like in this case, we say copper is being reduced. So that species that is being reduced, it means it is, we normally call it the oxidizing agent. It's the inverse. So if a substance is being reduced, then we call it the oxidizing agent. The same case for for the other one. So this is now the reducing agent. So oxidizing agent is that substance that easily gains electrons, while reducing agent is that substance that easily loses electrons in a reaction. So next we're going to look at the oxidation numbers and rules of assigning the oxidation number. Thank you.